back to the just now's example from the attachment in your chat room. Okay, this is a OneNote topic 3 week 9. So I'm going to show slope stability analysis taking from the previous example. Example question number 2. Okay, this is a problem. Okay, we have a slope angle and then this is the sector. The informations given here. Okay, the angle from the horizontal uphill of the slip is 48 degree, and also this one angle is 26. So the first one is that you have to get the 26 and 48. After you have that you open up the angle 26 from the two of the slope and you mark on top as a O, and from the intersection horizontal uphill with the open up angle 48, that intersection that is considered as a O. Make sure that when you draw this one, the slope height is equal to 8 meter. Okay. Okay, this is what we have. Okay, please mute. Okay. You open up 26 from the two slope, 26, and then from the horizontal here, you open up as a 48. Let's say the intersection here as a O. This as 48 degree. After you have the O, you need to find what is the radius. Actually, in this question also, it gives the slope angle. Slope angle is what? 1.5 to 1. So you can calculate the slope angle. When you have the slope angle, you can draw the slope geometry and also the slip circle. Again, when you draw on the graph paper, we're taking the scale 1 centimeter equal to 1 meter. It means that you have to draw the slope height. If you have that 8 meter, so the slope height 8 meter is equal to 8 centimeter. Please listen carefully by looking at these notes as I attach in the chat room, because this quite important in slope stability analysis. It's involved with the calculations. Okay, after we have the R, let's say you have the R with you measured the length from the toe of the slip to the O, let's say as a 12 meter, for example. How do you know that? Because you place the ruler from N here to the O as a 12 meter. So remember the radius from 2 to the O is 12. Is similarly from the starting of the slip circle at uphill slope must equal also as a 12 meter. The 12 meter here is equal to 12 centimeter. And then after we have all these important parameters, we have determined the R, and then we get the O, the sector angle theta. Okay, what's the next thing we need to do is that you have to divide the W here into equal width of the W1, W2. Okay, for this example, let's say we consider the first W let's say we consider W here as a 2 meter. How do you know that the 2 meter? Remember when you get, sorry, just now I forgot to mention that after you have the R equal to 12 meter, you know the sector angle, you can do the intersection using the, what we call it, a geometry set. Jangka lukis tu, you mark here, intersect at here, you open up from here, point, intersect here, you got the O, then you can draw the slip circle. So the slip circle must meet to the right point at two slope and also at here. If you are having the similar R, if you're not having the similar R, I mean that they may be wrong the locations of O. So you have to find the right locations of O so that the slip circle must meet at the two of the slope to the uphill slip circle here. Okay, let's say the first slide we divide into 2 meter. So the next slice must be divided equally with a 2 meter. Similarly to the next one as a 2 meter. Okay. Okay, next one is also 2 meter, 2 meter, 2 meter. So when you divide the vertical, there must be end to the slip circle because the slip circle is our boundary. What the effect if you extend the vertical height beyond the slip circle, you might have the wrong H value. Okay, this is the case where we do not consider yet the tension crack. Okay, the next one is that you have to find the location tension crack and its depth. It is calculated that the Z node is, so I don't want to show here how to calculate the Z node. You can refer from the slides given in the slide 40, sorry, in the slide 30. Slide 38. The slide 38 shows you how to calculate the tension crack and then the Z node. Okay, from the calculations, the Z node is equal to 2.5. Let's say we consider as a 2.5 meter. How do you get the 2.5 on the graph paper? Okay, let's place your ruler here. When you begin 0 centimeter at this point, it's still 0. So you go downward, move from the right to the left side until you can measure the vertical height ataupun vertical depth is equal to 2.5. When you still could not find 2.5, you need to shift more to the left until you can get as a 2.5. Let's say this is the 2.5 meter. So this is the locations of your tension crack, which the Z node is a 2.5 meter. Again, we considered the scale 1 centimeter is equal to 1 meter. Even though your calculation is in meter, and then when you measure on the graph paper, so it still can consider on the same scale because we assume 1 centimeter is equal to 1 meter. So as I said, what the effect of the tension crack is that the sector angle is reduced. So how do you get the new theta, the sector angle, due to the tension crack? A simple way is that you take from O here until to the end or to the bottom of the tension crack here. So the new theta, the new sector angle created due to the tension crack is opening at here. Let me mark as a theta C. How do you get the value of the theta C? So you have to place your protector. So you measure from this one as a baseline. You open up until you get the angle theta C. So from this one, let's say that the theta C is equal to, because the theta C will be reduced from original. So let's say theta C is equal to 80 angle. So the theta C is to be used in the formula. The theta C is taken the value in FOS. What's next? The next one is that you have to tabulate the table so that you can have the resistance force and also the shearing force. Before you can tabulate the table, as I said, you have to identify which one is the H1, H2, and what is the value of the B. Okay, in order to tabulate the table, this is the information that we require is a B, H1, H2, alpha, W, A, alpha, W sin alpha, and W cos alpha. So W sin alpha is a T, W cos alpha is a N. This is the resultant, this is the deriving component from the resultant W that occur in interslice of the W of the wake. What is the H1? I think that since we assuming that the B for each slice is equal, just now I mentioned 2 meter, slice 1, 2 meter, slice 2, 2 meter, slice 3, 2 meter, 2 meter, 2 meter, 2 meter, 2 meter. Okay, please be careful on the last slice here. Because of tension crack occurred in the last slice, so the B here could not consider as a 2 meter. You have to measure what is the B as a horizontal measurement. You just put your ruler here. What is the B from this slice to the tension crack? So it will be reduced to 1, for example. Let's say we assume B as a 1 meter. Okay, H1, for example, look at to the slice number 1 here. You put your ruler here. So H1 for slice 1 is equal to 0 because at these two slices. And then for H1, H1 is 0. H1, you place your ruler on top part here until the slip circle at this point. So as a H2. Let's say we assume that H2 is a 2.5. This one, I need you to redo in your own study. So that there is a guideline to check your understanding. Okay, let's say we assume the H1 for slice 1 is a 2.5 meter. How about the H1 and H2 for slice number 2? Okay, now we move to the slice number 2. The B still equal as the 2 meter because we said just now we have divided the W, the total mass W into equal vertical slices. So the B1, 2 meter, B slice 2 is 2 meter. How about the H? For H1 at the left side of interslice W2, this is the this is H1 for W2. This one is a W2. So H1 will be equal to the H2 of slice number 1 as a 2.5. And then how about the H2 for slice W2? So you place your ruler here, you measure from this top until the slip circle end. That is your H2 for slice number 2. For example, here is a 4.7. So that's process continuously occur. And then let's say we have determined H1, H2 for each slice 1 to until the last one. We want to calculate the area of the slice. Because we have so many slices, so the area will be changed accordingly to the value of H1 and H2. As I said, for this one, I am considering the area of the trapezoidal. The area of the trapezoidal is equal to 0.5 times B times H1 plus H2. Okay, that is the area of the trapezoidal. So when you tabulate the table, you have the area of the slice 1. You can multiply accordingly to the equations of the trapezoidal. So you have the area of the slice 1. And then same goes to this area for slice number 2. You have the B, you have the H1, H2 for slice number 2. You calculate by half, you can get the area for slice number 2. And what is the alpha? So alpha is another important parameter. Okay, how to find the alpha? The alpha will be changed sign accordingly to the positions of itself. So alpha can be negative or alpha can be positive. How to get alpha positive, negative? Okay. First, okay, just now we said each slice represent as the W. The W is the weight or unit mass of each slice. Where is the W at? The locations of W for each slice. W will act at the center of the slice. Let's say we have this slice 3, for example, the B is equal to 2 meter because we divided slice equal with 2 meter. So the centroid of the weight for slice number 3 is a half of the 2 because we assume that the W is acting at the midpoint. So that is the positions of the W. So W over 2, 2 over 2 is equal to 1. So meaning that you have to find 1 meter from left side here and 1 meter to left side here. That is the center of the W slice number 3. So that is the W slice 3. So where is alpha, the angle of interslice? How to find that one? Okay, this need to be careful. We take from the O sector angle and then they need to be meet at the slip circle out at the slice number 3. So that is the alpha, the interslice angle. Okay, as you look at here, the W3 is located at the right side. So when you look at here, from O to this point, so the W is located on the right side. Sorry, W is located on the right side. So the alpha is considered as a positive. So how to get the alpha? You just put your what we call it a sudut protector tu, and then you measure the opening angle. So let's say you can have the alpha is equal to 20 degree. And then what is the T and N? So you need to multiply W sine alpha. And N is a W cos alpha. Okay, I forgot to tell you how to calculate the W. W is equal to volume of the vertical interslice, which is gamma times with the area. That is the volume of each slice. If you have the W3, so the unit weight is constant because we have homogeneous slope. The area for each slice will be different. So area slice number 3, what's the value? So you multiply with the unit weight for slice number 3, that is the W3. So the important about the interslice angle need to be considered when you calculate the sine alpha and the cos alpha. Let's say you have W is equal to 20 kilonewton per meter. And then W sine positive 20 degree or W cos positive 20 degree. If you have the W is located on the left side of the sector angle, or sorry, at the left side of the center of the slip circle, so the alpha that you measured from here to the W here is located on the left side of O. Therefore, the alpha is equal to negative. Let's say you measured the alpha is equal to 5 degree. So when you tabulate the table, the alpha for slice number 1, slice 1 is a negative 5 degree. The negative 5 degree must be included when you calculate the T and W. For example, W1 sine negative 5 degree. And then W cos negative 5 degree. Again, for your slope stability calculation, alpha and theta must be in the radian unit. How to convert the radian unit? By having the such as If you have the theta C just now 80 degree, how to convert to the radian? Is that 80 over 180 times with the pi. That's how you calculate to convert the angle into the radian unit. Okay, when we complete on this part, we have determined the B1, H1, H2 and H3, H1, H2, B, W, alpha and A. Then you need to tabulate the table. After you complete the table from slice 1 to the last slice here, you can calculate the FOS for all cases. So any questions? This is very important because I think that the calculations answer you can see from the handout given just now. How to construct the slope, that is important for you to understand. If you're having a problem or if you're not clear on my explanation just now, please open or turn on your microphone so that I can understand or I can ensure that you are clear on this part or you're not clear on this part. Because as I said, the slopes chapter 3 will be covered in your first assignment. So this is I took example from handout in solutions or example number 2. That's how you can follow back. You construct your slope and then you tabulate the table, and the next one you calculate on the FOS having the tension crack empty of water with a tension crack full of water. Any question?
Tak ada.
Sure?
Saya rasa kena buat exercise dulu.
Yes, I think that for the first one is that you just follow back to my hands out. Concentrate on this example and any examples in the hands out given just now. Redo, hands on, manually draw the geometry, calculate the FOS, determine the B, H1, H2, and then the W, alpha, etc. important parameters. Then you know, are you ready to take the assignment 1 or not? Because the implementations of the assignment 1 is same to your common test. It's a closed book. It is totally rely on your understanding. If you having a problem to construct the slope geometry, then we be stuck for the whole 2 hours assessment durations. Remember is that when we are dealing with the slope stability, actually we need to find the most critical FOS. But this somehow we want to reduce the few trials, so we just give you the slope geometry, slope angle, all other informations. So you come out with the value FOS. You justify, is it the slope stable or not stable according to the calculated value. The next one is that let's say you calculate then you get the FOS less than 1. What's the next thing you need to do? So you have to do some other things, such as maybe you need to change the geometry of the slope, because we couldn't change this the soil parameters. But the things that we can control is on the slope geometry, because remember, assuming that you as a geotechnical engineer, you have a proposed sites to construct a retaining wall on the slope on the hill slope. That's your case area, your potential site. So the whatever soil parameters there, you couldn't change, because you are given that is the site you're going to construct a slope. What you need to do is that when you analyze the FOS, you design it with the first angle is failed. So the next thing what you need to do, and then you have to find out is that any water table effect, and what are other things, important parameter control to your FOS value. I think Truly said, I'm sorry because it's quite difficult to explain online learning. Basically, we can do hands-on. Let's say I give you few times because we have remaining 20 minutes before our class end. You look at to the hands out just now, and then try read on the questions and informations. What are the things that you might not clear? For example, maybe you're not clear on the H1, H2, how to begin, start drawing the slope. Because as I said, if you do not have the radius of the slip circle, you couldn't solve the problem. Or one information missing, so uh, there will be starting off to think how to find missing parameter. So there's a lot of possibility happen when you are analyzing the slope stability. So let's say R is not given, slope angle is not given. What are you going to do to start off the analysis? That's the things I need you to figure out, because the slope angle might be in the same draw in the same pattern. It can be in various angles or in various shape. So you have to do a lot of exercises to reach out what kind of solution suit to this problem. Maybe problem A is not suit to the solution B, so it has its own, but the method of processing will be similar to all problems. So I give you 5 minutes more. If you feel that you don't have any problems, you know how to do it, this one, hands on, manually calculation by your own, then we'll be fine. Because as I said, there's only 2 weeks left before you having a assignment 1. I'm not sure what strategies are you going to use in the assignment 1. We have seen the strategies in common test. So we can see the same trend answering the common test. But the thing is that you have to remember, when you are taking the test or assignment, there's something that you have to bear in mind, is that whatever strategy you use to answer the question, is it berkat ke tak berkat? Because nanti you yang nak kerja kat luar tu, tak ada kawan pun yang nak bantu you untuk you jawab. It's rely on your understanding. Okay, 5 minutes more before we end our class. Let's say you don't have anything to ask. It's quite tough because our class start 8 a.m. So I know some yang masuk lambat. Okay, you can check on the slide given for topic 3. And there's also additional notes on the slope stability using the limit equilibrium method and also the finite element method. So for your information, this is the approach of limit equilibrium method. So the limit of equilibrium method is, you can see that the few trials involved to get the most critical failure of surface. When we say that the most critical failure of the most critical failure of safety is that you have the FOS less than 1, that is the prone to having a slope failure. If you calculate the FOS is more than 1, so the design is safe or good. Remember again, when you want to calculate the FOS, you have to check whether the slope in long-term stability or in the short-term stability. I mean that, for example, if you construct embankment, a new embankment, you want to check immediately the stability of the new embankment. So you cannot use the drain strength parameters. What you need to use is that the undrained strength parameters, especially in the saturated fully saturated clay. Because during that time when you apply loading, there's no pore water measurement, there's no pore water measured. But when you analyze embankment after few years, just to do a maintenance work to check the stability of the slope, during that time we will consider the long-term stability using the drain strength parameters. And during that time also, there's a pore water pressure measured. So you might see that the FOS value will be changed, sama ada dia increase ataupun decrease with this some kinds of additional factors or additional forces moments such as hydrostatic force. Okay. I think that I leave you to do your hands-on exercise for all the examples given in the hands up. Again, for this chapter 3, you couldn't read only to understand this topic. You have to hands-on calculations, take it a graph paper, get all your geometry set, try to do one example from this hands up. Are you going to get the same value or not? And then if you have same answer, you have developed your basic understanding, move to the second example, strengthen the previous understanding, then you will confident you are ready to take the assignment 1. I think that any question before I end this class of morning?
No.
Okay, thank you. Assalamualaikum.
Thank you, madam.
Thank you, madam.
Salam, Doctor.
Thank you, madam.
Thank you, madam.
Thank you, Doctor.
Thank you, madam.
Thank you, madam.